7.5 areas of regular polygons. Circles can be inscribed, which would mean they're inside, or circumscribed about, meaning they're around or outside any regular polygon. So basically what that means is if I have this triangle, I can draw a circle inside of it. That would be inscribed. I can also draw a circle outside of it. Let's fix that a little bit. So either way, we can take a regular polygon, any shape, and we can either draw a circle inside or outside of it. Since the center of the inscribed and circumscribed circles are the same point, the common center of these concentric circles is called the center of the regular polygon. So let's say we had a square. If I draw a circle inside the square or around the square, the center is going to be the same. The center is the same as the red circle, it's the same as the square, and it's the same as the blue circle. A radius of a regular polygon is a segment that joins from the center and a vertex of the polygon. So if I have this figure drawn, and this is my center, okay, say my center is C, the radius would go from the center to any of the vertices. Just like if I were to draw a radius here on this circle up above, that would be a radius of the circle. But the radius of the polygon would go to the vertex. The central angle of a regular polygon is the angle formed by drawing two consecutive radii. So if I have a pentagon again, and this is my center, I could draw this radii to this vertex and this radii to this vertex. They're consecutive, they're one after another, and this would be considered my central angle. The measure of any central angle is going to be found by doing 360 divided by n, where n is always our number of sides. So for example, if we have an octagon, that would be 360 divided by 8, because there's 8 sides in an octagon, which would give me a central angle of 45 degrees. So each of the central angles would be 45 degrees, all the way around would be 360. An apothem of a regular polygon is perpendicular, meaning it's going to form a right angle segment that joins the center to the side of the polygon. So remember, the radius joins the center to a vertex. The apothem joins the center to the side. We have the same shape we've been looking at, this pentagon, and this is my center. My apothem would go to one of the sides, and it would form a right angle. So maybe you can kind of see where we're going with this. If we have a central angle and we draw an apothem, we would be cutting that angle in half. Okay, we would also be forming a right triangle. We know how to solve for sides of a right triangle using the Pythagorean theorem. Therefore, we're going to be able to get this equation for the area of any regular polygon. So the area formula for a regular polygon is 1/2 the apothem times the perimeter. A is your apothem, and P is your perimeter. So let's try some examples. Let's go back to an octagon. Okay, this is a regular octagon. That means all of the sides are equal. We'll say they're each 10. Okay. Draw the radius and an apothem. So my area formula would be 1/2 apothem times the perimeter. I'm given the apothem. I'll need to solve for the perimeter first. Well, there's 8 sides, and they're each 10 centimeters, so that would be 80 centimeters. And now I can plug it in. 1/2 apothem times the perimeter. And I can plug that into my calculator to find my area is 484 centimeters squared. Let's try another one. Let's say I'm given a hexagon this time. Okay, it tells me it's a regular hexagon, so each of the sides is the same. They're all 4 inches. Okay. And it gives me this picture where this is the center, and this is my apothem, but it doesn't give me what the apothem is. So I know I need 1/2 apothem times perimeter. I'll start with perimeter since that's the most simple. There's 6 sides, each of them 4 inches. So my perimeter is 24 inches. Now I'll need to solve for my apothem. Well, when my apothem's drawn, I cut the central angle here in half, and I also cut this side in half. So I know that this piece is 2. Okay. Now let's figure out what our central angle is. Central angle I would solve by doing 360 divided by the number of sides, which in this case is 6. To find each angle is 60 degrees. Okay. 60 degrees cut in half gives me that this is 30 degrees. So it looks like I have a 30, 60, 90 triangle. I'm going to draw it out over here. Can't use Pythagorean because I don't have enough of the sides, but I can use my special right triangles that we learned yesterday. So I'm going to draw out my chart. S square root of 3, and 2s. Across from 30 is 2. Across from 60 is my apothem. And I'm not concerned with what's across from the hypotenuse, so I'm not even going to fill that in. Remember, anything in the column is equal. So if s is 2, then my a is going to be 2 times the square root of 3. So I have all my pieces, and I can plug it in to my formula. 1/2 the apothem times the perimeter. Now when you plug something like this into your calculator, I would start with the square root of 3, type in 3 square root times 2 times 24, either times 1/2 or divide the whole thing by 2 to get 41.6 inches squared. So that's the end of section 7.5. You can either look on Google Classroom or your assignment sheet for your homework tonight.